Good day, esteemed researchers and curious minds tuning in from around the world. Today, we delve into the fascinating realm of creative problem solving in large language and vision models. What would it take? This groundbreaking research, brought to you by Lakshmi Nair, Ivana Gizzi, and Jivko Sinapov, explores the untapped potential of computational creativity in enhancing the problem-solving capabilities of large language and vision models. Stay tuned as we unravel the mysteries of machine learning and creativity. In our research, we delve into the intriguing realm of augmenting LLVM embeddings. We draw inspiration from the principles of computational creativity, or CC, to enhance these embeddings for creative problem solving. This approach opens up new avenues for innovation and discovery in the field of machine learning. We also propose an experiment to put these principles to the test. The experiment is designed around the concept of transformational creativity, as outlined in the Object Replacement Object Composition, or OROC, framework. The focus of this experiment is on tasks that require the innovative replacement of missing objects. This approach allows us to explore the potential of LLVMs in a new light, pushing the boundaries of what these models can achieve. In essence, our research is a journey into the uncharted territories of LLVM embeddings, guided by the principles of computational creativity. We're excited to share our findings and look forward to the discussions they will spark. Our experiment setup involved two distinct groups. The first, a nominal group, where the actual object itself is available and requires no replacement. The second, an object replacement group, where the nominal tool is missing and a creative replacement object should be chosen. We then compared the performance of models in these two scenarios. The results were quite revealing. When no creative replacement was required, the models performed well. However, they struggled when tasked with creative object replacements. Interestingly, we observed an improvement in model performance when we provided additional information about the object's affordances. This aligns with the principles of the OROC framework, suggesting that augmenting LLVMs with object affordance information could be a promising direction for enhancing their creative problem-solving capabilities. Computational creativity, or CC, is a multidisciplinary field that aims to generate creative outcomes akin to those of humans. As we can see in the figure, it has the potential to significantly enhance the creative problem-solving capabilities of large language and vision models, also known as LLVMs. This opens up a new avenue for LLVMs to not only understand and interpret tasks, but also to approach them in innovative and creative ways, much like a human would. This integration of computational creativity into LLVMs forms the crux of our discussion today. Creative problem solving is a key aspect of computational creativity, or CC. It involves finding innovative ways to complete tasks. For instance, imagine using a bowl in place of a ladle. However, we've identified a limitation in language and vision models, or LLVMs. While they excel in artistic tasks, they often fall short in creative problem solving. To illustrate, consider real-world examples of creative problem solving, such as the makeshift CO2 filter in Apollo 13, or the creation of makeshift medical devices during the COVID-19 pandemic. These instances highlight the importance of creativity in problem solving. This brings us to the need for computational creativity in LLVMs. It's crucial to address this limitation, and we advocate for a stronger integration of machine learning and computational creativity in research. This will enable LLVMs to not only generate art, but also to creatively solve problems. Bowden's three forms of creativity, exploratory, combinational, and transformational, offer a fresh perspective on enhancing the creative problem-solving capabilities of large language models, or LLVMs. The exploratory approach, often associated with search in machine learning discussions, involves navigating the model's embedding space to generate novel outputs. However, the real potential lies in the combinational and transformational modes. Combinational creativity involves merging concepts within an LLVM's embedding space to produce something new, while transformational creativity involves altering the existing conceptual spaces to create new ones. These two modes, we believe, are crucial for enabling creative problem-solving in LLVMs. Our research aims to enhance the creative problem-solving capabilities of LLVMs by integrating principles from computational creativity, specifically transformational creativity from the OROC framework. Currently, LLVMs struggle with creative problem-solving, a limitation we aim to address. We've identified this lack of creativity as a significant hurdle and propose a solution that involves a more holistic approach. By focusing on transformational creativity, we aim to enable LLVMs to re-represent tasks, making the solution more evident. This approach could potentially revolutionize how LLVMs tackle problem-solving, opening up new avenues for innovation and discovery. Our approach to the problem involves augmenting language and vision models, or LLVMs, with information about object affordances. This is based on the Object Replacement and Object Creation, or OROC, framework, which suggests that understanding an object's potential uses can lead to creative problem-solving. To test this, we designed an experiment. In this experiment, we created test sets composed of images, each representing a potential replacement for a core object. We divided these into two groups: nominal, where the actual object is available, and object replacement, where a creative substitute must be identified. The models were then tested on their ability to identify the correct replacement object. This experiment design allowed us to assess the potential of LLVMs in creative problem-solving, and the results provide valuable insights into their capabilities and limitations. In our research, we utilized versions of the CLIP and VLT models from Hugging Face, experimenting with different model sizes and patch sizes. Our approach diverges from previous methods by emphasizing the integration of principles from computational creativity, or CC, to enhance the creative problem-solving capabilities of language and vision models, or LLVMs. We proposed a unique experiment setup to validate the principles of object replacement and object recontextualization, or OROC. This setup tests the model's ability to creatively replace objects, a key aspect of problem-solving. Our findings suggest that incorporating CC principles can indeed improve LLVM's performance in creative tasks, opening up new avenues for further research in this area. Our experiments tested the principles of transformational creativity from the Object Replacement and Object Creation, OROC, framework. We set up two groups: a nominal group where the actual object was available, and an object replacement group where a creative replacement object should be chosen. The models we used included versions of CLIP and VLT. In the nominal test group, where the object required no creative replacement, the models performed exceptionally well, with over 90% accuracy. However, when the object required a creative replacement, the models struggled, highlighting their limitations. Interestingly, when object affordance information was provided, we saw a general improvement in model performances, consistent with the OROC framework. However, additional information about the task or both task and affordances did not lead to substantial improvements. These preliminary experiments suggest that principles from computational creativity can help overcome limitations of LLVMs in creative problem-solving. The notion of task re-representation via improved prompting warrants further investigation. As we delve into the conclusions of our research, let's take a moment to appreciate the figure on display. It represents the average accuracies of the models across different seed settings in the object replacement group, a key aspect of our experiment. Now, Let's reflect on the importance of computational creativity, or CC, in machine learning. Our research has shown that CC can significantly enhance creative problem solving in LLVMs. This is a crucial finding, as it opens up new avenues for innovative solutions in task planning. By integrating principles from CC, LLVMs can be equipped to generate novel substitutions for missing objects and devise appropriate trajectories for their creative use. In essence, our work underscores the potential of a more holistic approach to problem solving in machine learning, one that leverages the insights from computational creativity. Our research has shown that both high and low-level language learning models, or LLVMs, can be adapted to incorporate creative problem solving. This opens up the potential for novel substitutions and the generation of creative trajectories. Despite the importance of this, we've noticed a lack of focus on creative problem solving in major machine learning conferences. We believe there's a need for a deeper integration of computational creativity communities at prestigious venues like ICML, ICLR, and NeuraPS. We encourage a holistic view of creative problem solving and machine learning. By viewing machine learning through the lens of computational creativity, we can promote a more comprehensive understanding of creative problem solving. This approach not only broadens our perspective, but also paves the way for innovative solutions in the field. In our research, we've drawn upon Margaret A. Bowden's 3 forms of creativity: exploratory, combinational, and transformational, and considered their potential extension to large language and vision models, or LLVMs, to enhance their problem-solving capabilities. We've conducted preliminary experiments focusing on transformational creativity. These experiments demonstrate the application of this form of creativity in LLVMs and show promise for future research in this direction. However, we believe there's a pressing need for a broader discussion on computational creativity. This is essential for addressing the current limitations of LLVMs in creative problem solving. We encourage the machine learning community to consider how LLVMs can be augmented with creative problem-solving skills, drawing from the rich insights of computational creativity. This integration could push the frontiers of these models' ingenuity and open up new avenues for exploration.